Hello, so today I will teach you how to use MG-RAST. MG-RAST stands for Metagenomic Rapid Annotation using subsystem technology. So you go to Google and type MG-RAST. After that, choose this one, tap on this, and it will open into this. After that, you need to type what type of sample you want to use. For example, you want to use mangrove sediments, and then search. After that, you will get this kind of output, and then choose the data that you want. You can scroll up to the bottom, and then you can see here the country with where the data come from, location, the type of biome, aquatic sample, mangrove sample, and then the sequence type. There are shotgun metagenome and applicon. There are two type of the sequence. So this is the project name or the metagenome name, and this is the title of the study. Let's say if you choose other sample, you can just type here productive zone 2 and search. After that, if you want to choose, let's say you want to use this data, you can click on the metagenome name or the study name. I just click here. Then it will give the output or the summary of all the info that you can extract out. Like this one, MGM 4625350.3. This is the ID, and the project name is here, productive zone 2. So these two data you can include in the table 1 for the section result. But this data is assembled by the Professor Alexander Shu Chen Cheong from the University Science Malaysia, and the study name is Mining of New Genes and Pathway from Soil of Mangrove Forest 2. So this data, all the thing like the total sequences, the RNA genes, 0% RNA gene, and 2995841 predicted proteins, all the data you can extract here to be included in the table 2. Right, so for the table 3, we need to do analysis. We can use the name, copy this, or you can use the ID. I just use ID, copy this one. After that, you can go to the analysis page. Then we can perform the analysis. This is how it looks like. Then adjust from name to the ID. But if you use the name, you just choose name and then you type here productive zone. Okay, so for me, I will use ID, then paste here. After that, press enter. So it will show like this. Tap on this and tap to this arrow, choose add available databases. Another one, you need to add the subsystems. Make sure the selected databases are reference sequence and subsystems. After that, you can press on the tick button to run or perform the analysis. This will take some time, around like 5 to 10 minutes. Right, so it's already running the analysis. We just need to wait until it will come out the analysis name here that we, if you rename it, like you want to give a title or a name as mangrove analysis or mangrove biome, then here it will come like mangrove. If you don't give any name, you will see like analysis 1, analysis 2, and so on. Okay, so just wait for both to settle, the subsystem and refsec. Then we will proceed with the next section, which is to analyze the data that we obtained. But if you fail to analyze the data, means that if you wait for more than like 15 minutes but it's still not moving, then the data is got a problem, the error, meaning that the data is too old and it is broken, cannot be used to analyze. Right, so this one already complete. We need to wait for the another one, which is the database for the reference sequence to be complete. When both are complete, then you will get the output like in a table right here. Lama lah pula tunggu. Right, so we will see this is the productive zone, and all the sequence has been already break down into the fail QC, unknown sequences, predicted feature. All this data need to be included in the table 2. The unknown protein, annotated protein, and ribosomal RNA analysis statistics. Functional hits, you can look at the taxonomic hits, the subsystems. We will analyze on the carbohydrates. Nah, hujan. The phylum, this is the most dominant phylum for the selected sample, which is the mangrove biome. The most significant phylum is the proteobacteria. There are so many types of proteobacteria. Class A, alpha, beta, gamma, delta proteobacteria, yes, gamma, alpha, clostridia. Minggu satu lagi. Minggu depan last week 14. Minggu nak masuk minggu 14. Lepas tu study week lah. Tak weh, 14 je. 7. Dan lepas tu mid sem kan. 7 separuh dah mid sem. Lepas tu 7 lagi habis yang tu study week. Ya. Exam start Julai. Aku 10 ke 13 macam tu lah. Tapi hari awal jugalah. Dia awal dan penutup. Ya. Tak tahu lah, school bayar memang macam tu. Suka mengejamkan. Ha? Bukan selpa daripada first year lagi kita. Ya. Lama dah macam ni, dah biasa dah. Betul. Sampai dah last syndrome paper. Tak ada semangat dah nak study. Lamanya loading lah doi. This is another sample. The title is ECM15M PS05R1A by Angel, University of Tennessee, Department of Planetary Sciences. The data ID is MGM471402.9.3, and this is the summary of the sequence breakdown, predictive features, analysis statistics, nucleotide histogram, source hits distribution, taxonomic hits, bacteria, archaea, eukaryota, phylum, and this sample from the coastal sample also dominated by the proteobacteria. Classes gamma proteobacteria is most abundant, followed by delta proteobacteria and alpha proteobacteria. Planktomycetacea, beta proteobacteria, actinobacteria, clostridia, flavobacteria. Other orders that exist, desulfobacteriales, actinomycetes, rhizobiales, and the family, genus, everything can be checked here. Rank abundant plots, you can see the sample started to plateau here, and all the sample search output. Okay, we almost finished with the analysis, but it's still running. Dua, tiga, kucing berlari, anak semua dengan kucing berlari. Okay, almost there to for 0.5 megabyte. Then complete. Okay, so your data is loaded and ready for analysis. Look at here, the analysis one. But if you rename the analysis, you give a name like mangrove, then it will come out here like mangrove 1. So go to the type of data. Let's say you want to be in the table, then press table. This is the summary. You can see the domain, the how much RKR contain, how much bacteria, and then you can see in the pie chart. After that, the bar chart, stacked bar. Okay, so how to run the analysis on the carbohydrate content. Choose the level, genus. Wait, okay, genus. After that, tap on the filter, reference sequence, domain, functions, filter, level 1. Here should be genus, and type for carbohydrates. Add. Okay, so right now, view in table. This is the table of analysis 1. You can see the genus here, Aeropyrum, but the number is not line, so you need to descending. You need to sort the data to descending order, so we can analyze the data. The first genus is Roseflexus, that has a number of 41,806, followed by Clostridium. Clostridium have 39,430, and Geobacter you can choose up to 1, 2, 3, 4, 5 ranking. Okay, so this is the answer for the table 3. After that, you need to run another analysis for the coastal sample. Let's say using this data, ECM 115M PS05R1A, the same method like I have shown here, and that's all. You can also do in the pie chart, stack bar. Okay, that's all from me. Thank you.